It's something we do dozens, maybe even hundreds of times a day without even thinking about it. But have you ever actually wondered what's happening behind the screen? Well, in this explainer, we're going to pull back the curtain and break down the incredible engineering journey that happens in the blink of an eye, all from a single, simple click.
I mean, really think about it for a second. You tap that little heart or the thumbs up, and poof, a number somewhere ticks up. But what's actually going on in that split second? It's not magic, I promise you. It's more like a lightning-fast, globe-spanning relay race. And today, we're going to trace that entire path from your screen all the way to the cloud and back again.
Yeah, so from our end, it's all super simple, right? We tap a button. We might see a little spinner for a fraction of a second, and then boom, the light counter goes up by 1, our job is done. But that's just the tip of the iceberg, you know? The real story, the amazing part, begins the exact moment your finger lifts off the screen.
So how does your simple tap on a screen turn into something a computer, maybe thousands of miles away, can actually understand? Well, it all starts by turning that click into a message. And for that, we need to talk about the unsung hero of the internet, the API, which stands for Application Programming Interface. Just think of it as the system's official messenger.
Okay, so probably the best way to get your head around an API is with this analogy. Imagine the app on your phone is you, a customer in a restaurant, and the server in some faraway data center, that's the kitchen. Now, you don't just walk into the kitchen and start making your own food, right? Of course not. You give your order to a waiter. The API is that waiter. It takes your request, hey, I'd like to like this post, and carries it cleanly and correctly to the kitchen.
So to put it a little more formally, an API is just a set of rules that lets different software programs talk to each other. It basically defines how they're allowed to communicate, how to ask for something, what kind of answer to expect in return, and what language to speak. It's basically a contract that makes sure the communication between the client, that's your app, and the server goes off without a hitch.
Right, so every message has to be written in some language. And for APIs, two really common ones are JSON and XML. Now just look at the left, that's JSON. It's clean, it's compact, it's easy for both people and computers to read super quickly. Then on the right, you've got an older format, XML. It's a lot more, well, chatty. It uses all these opening and closing tags for every single piece of information. And it's for that reason, that clean simplicity, that pretty much all modern APIs, the kind that power the apps we use every single day, speak JSON.
All right, so we've got our like request all neatly packaged up in a JSON message. Awesome. But how does it actually get from your phone to a server that could be on the other side of the planet? Well, it travels on the internet's superhighway, using a set of rules called HTTP, or Hypertext Transfer Protocol.
Now, the full journey is, well, it's actually got something like 19 different steps, but we can boil it all down to these 5 main stages. First, a DNS lookup happens, which is basically the internet's phone book. It turns a name we can read, like socialsite.com, into a numerical IP address the computers can use. Then the request is sent. It might get directed by a load balancer, think of it as a digital traffic cop, that makes sure no single server gets too much work. The server finally gets the message and does its job. And then, crucially, it sends a tiny response back saying, yep, got it. And that's what makes the light counter on your screen finally update.
Okay, so the message has arrived. The server got our like request. Now what? Before it can save it permanently, it needs to organize this new piece of information in its short-term memory, its RAM. And to do that, it uses something called a data structure. It's all about keeping things organized, so the computer can find stuff really, really fast.
So to do this organizing, engineers use these really foundational tools, and the analogies on this slide are just perfect for explaining them. On the left, you've got an array. Think of it like a train. All the cars are connected in a perfect sequence, stored right next to each other in the computer's memory. Then on the right, you've got a linked list. This is more like a treasure hunt. Each piece of data holds a clue, or a pointer, to the location of the next piece of data, which could be anywhere in memory.
And this is where it gets really interesting, because this table shows you why you'd pick one over the other. If you want to jump straight to the 10th car in that train, the array, it's incredibly fast because everything's in order. But if you want to find the 10th clue in the treasure hunt, the linked list, well, you have to follow the first 9 clues to get there. It gets slower and slower the bigger the list gets. But the reverse is true if you want to make changes. Trying to add a new car to the middle of a train is a huge pain. But with the treasure hunt, you just change a couple of clues. See? It's all about picking the right tool for the job. But here's the thing. That server's short-term memory, it's temporary, like really temporary. If the power goes out, our like is just gone.
forever. So for the final step, that little like of ours needs a permanent home. It needs to be stored safely and for good in a database, which you can think of as a massive, super organized digital library.
And when it comes to these digital libraries, there are really two main philosophies. On one side, you have SQL databases. These are like a perfectly cataloged library with super strict rules. Everything has its place and neat rows and columns, like a spreadsheet on steroids. They're incredibly reliable. On the other side, you have NoSQL databases. They're more like a collection of flexible digital file folders. They are built for pure speed and can handle gigantic amounts of rapidly changing data, exactly what you need for social media feeds and, you guessed it, likes.
And there you have it. We followed a single like from a simple tap on a screen through an API across the entire internet into a server's short-term memory and finally safely into a database. And it all happened in less time than it takes you to blink. See these things? APIs, data structures, databases, they're not just jargon. They are the literal building blocks of our entire digital world. Once you really understand how they all fit together, you can see the blueprint behind pretty much every app and website you use. Which of course leads us to the final question. Now that you know how it's all built, what would you build?